Hello everyone. We're going to continue looking at classifying chemical reactions by looking at acid-base reactions. Um, I would actually probably reword this learning objective. So identify common acids and bases. I think a better way of saying this is predict the result of acid-base reactions. And part of that does include identifying these. So we'll approach this very similar to how we did precipitation reactions, but we'll be looking at another very specific type of ionic reaction that's going on. So let's go ahead and move into that. So an acid-base reaction is something we'll explore in more detail in the second semester, but for now, we can understand this by defining an acid and a base. So an acid is something that contains hydrogen ions. And for now, we can recognize an acid by looking at its formula. And if the first element in the compound is hydrogen, then we know it's an acid. You might see water as sort of an exception, but we'll get in, again, we'll see more about water going forward. For now, other than water, if you see a hydrogen at the front, that's your clue that you're looking at an acid. So what happens with an acid is that when you dissolve an acid in water, the acid will form something called a hydronium ion, which is basically a water with an extra hydrogen, and because of that, it has a positive charge. So we're showing that process here. When this occurs, you'll have whatever else present will be left over as a counter ion. We could think of it as sort of a spectator ion. So we're making hydronium ions when we form an acid by dissolving it in water. Your book talks a little bit here about strong and weak acids. That is something we will get into more detail on actually in the second semester of the course if you go on to take that. For now, just be aware that there is that distinction that will show up, and we're not going to get into the details of that right now. One thing I will point out, though, is you'll notice this particular acid, this is acetic acid. We'll be using it actually in the course, and it's one of the more common weak acids, but it's often written in several different ways, and you'll notice the hydrogen is not at the front, but at the end. So just kind of be aware that that sometimes shows up in that way. It also shows up, this one, you'll probably see it a lot in your biology classes as well, if you're taking a biology course. So some common strong acids, I want to just point out the ones we'll be using in this course. So we have hydrochloric acid is important to know. Nitric acid is important to know, and sulfuric acid is important to know. So these are important. When I say important to know, what I mean is that you'll be seeing these in lab, and you'll need to be able to see their labels either as a formula or as the compound itself, and be able to grab the right bottle when you're looking for one of these this semester. Okay, so those are some common strong acids. A base is something that will produce hydroxide ions when it dissolves in water. Here we're showing an example of sodium hydroxide is a solid, but if we put it into water, it breaks apart into sodium ions and hydroxide ions. So it is a base because one of the ions it produces is hydroxide. Similarly, there's a discussion here of strong and weak bases. We're not going to worry about that too much until next semester. But the most common of the weak bases is ammonia, and you can see it there. And then let's go ahead and talk about then the neutralization reaction. So a neutralization reaction is a reaction between an acid and a base, as a result of that reaction, we're making salt and water. So acid plus base to result in a salt and a water. Now let me just clarify what we mean by salt. We don't mean necessarily table salt. It could be table salt, but salt is here referring to any ionic compound that does not contain hydroxide. And then water is always going to be H2O. So here we're showing an example of a neutralization reaction. We have this thing. It does contain hydroxide, so it is technically going to be a base. We have this thing that starts with a hydrogen, so this is technically an acid. Well, it's a strong acid. It's one of the most common acids. So when they react together, we know we're going to make water, and we're going to make a salt, salt being any other ionic compound. You should be able to predict these reactions in a similar way to predicting a precipitation reaction. However, it's actually even a little bit easier because you know one of the products every time is going to be water, and the water is H2O, and within that, the O and the H come from the base, and the other H comes from the acid. So in balancing these, what you want to do, you want to say, okay, we know we have water. So how many hydroxides do we have? We have 2 because of the subscript. That means we need 2 of the hydrogen, so we add that subscript there. I'm sorry, I said subscript. So we add the coefficient 2 in front of the acid, and then everything else goes together to make the salt. So in this case, we have magnesium and chlorine, or chloride, I should say. So we have magnesium chloride, and the coefficient of 2 in front of the HCl becomes a subscript over here. And that also works with balancing. We have a +2 and a -1, so we need 2 of the -1s for that to balance out. So you should be able to write if you're given just the reactant side, predict the product side in a way similar to what you did for a precipitation reaction. However, here we always know we're making water, and that hopefully makes it a little bit easier. We also don't need to look up anything here on a solubility chart, so hopefully that will help with that as well. So some examples here. There's also some interesting discussions. Acid-base reactions are very important in a lot of aspects of our lives. Here it talks about stomach acids, and then other, food-related acid properties. And I think there's a little discussion here about ammonia being important in agriculture, which of course is very important where we live. So that is it for this section on acid bases and neutralization reactions.